Good day all. Welcome to BCPS-TV for Mathematics 6. This video supports the print and digital lessons for the week of May 11th. Well, hello again. It's Miss Rudolph. I will be your host this week. Thanks for joining in. This is a picture of me and my husband, Mr. Rudolph. I've included Mr. Rudolph again because, well, he does like attention. Next week, your Math 6 video will be hosted by the amazing Miss Barr. Some of you might know her from visiting your schools. She is seen here with her husband, too. A little secret for you? We are both married to Scots. We joke all the time about, what did your Scot say? Well, what did your Scot say? We sure do laugh. There are 3 other ladies in our office who are also married to Scots. It's quite the riot when we all get together and talk about our husbands. Before we get started, I'd like to share a few things about me. First, I grew up in Dundalk and graduated from Patapsco High School in 1994. One of my favorite places to still visit in Dundalk is Squire's. I just love their pizza. One of my favorite cities to visit is San Antonio, Texas. It's a very cool city. What you see here is the Riverwalk that extends beneath the streets of San Antonio. It is over 2.5 miles long. It boasts many hotels, restaurants, stores, and beautiful greenery and birds with the San Antonio River running through it. I just love it there. My favorite number is 8. It was my lacrosse number in high school, and now my daughter wears the number 2 as she plays soccer and basketball. My son was also born on August 18th, the 8th month, and my daughter was born in 2008. My favorite sport is soccer. I still love to play and love watching my daughter play. Man, it's really weird not having sports on TV. One of my favorite things to do, new favorite things to do, is walk the dogs. As you remember, I have a 100-pound English Mastiff and a 22-pound mini Golden Doodle. It gets quite hectic sometimes, but typically the little dog is pulling me and I am pulling the big dog. And my social media go-to is Facebook. I do tweet, but don't snap or chat or tick or talk or house or party or Insta-inagram. I'm embarrassing my daughter right now, and I absolutely love it. Yep, Facebook is the one for me. Yes, according to her,
she's a Facebook mom.
So let's move on to math. This week, students will be able to use absolute value to find distances between points, find area and perimeter of polygons, all in a coordinate plane. I'm so excited. Let's watch as our educational partner, LearnZillion, teaches us to find the distance between points on a coordinate plane using absolute value.
How far apart are these points? In this lesson, you will learn to use absolute value to find distances between points with the same x and y value by using a coordinate plane. Now let's review absolute value. The absolute value of a number is the distance the number is from 0 on the number line. Here's an example. Let's look at 3. 3 is 1, 2, 3 units from 0. So the absolute value of 3, or the distance 3 is from 0 on the number line, is 3. Let's try negative 3. Negative 3 is 1, 2, 3 units, this time in the negative direction. But still, the absolute value of negative 3, or its distance from 0, is 3. Now, a common mistake that I've seen people make is that they begin by moving along the y-axis first and then along the x-axis when they're finding an ordered pair. So they might start and move up first on this for 6, 4. They might move up 6 units as opposed to moving correctly on the x-axis and then over. And you'll see that that's not the right point for that ordered pair. A second common mistake that I've seen people make is that they return to the origin after plotting the x value and then they move on the y-axis. So if the ordered pair was 6, 4, they would plot a point at 6 and then go back to the origin and plot a point at 4. Now the ordered pair of 6, 4 is just one point on the coordinate plane. All right, let's start by plotting this first point A on the coordinate plane. A has a positive 6 and a positive 4. It's going to put it in quadrant 1 at point A, 6, 4. Let's try point B. at 6, 0. Now it has a positive x value of 6, but it has a 0 value for the y value, and so it doesn't move anywhere. It stays right there on the x-axis. Now the question for today is, what's the distance between these 2 points? Now we could count the distance as units from one point to the other, kind of like this. I could just start counting. 1, 2, 3, 4 units. And I can see that the distance is 4 units. But you know, there's a much more effective way, and this is using absolute value. All right, in order for us to find the absolute value, the first thing we do is we notice that, hey, guess what? Both of these ordered pairs have the same x value. Now, because they have the same x value, we're going to find the distance between the y values. Now, we want to find the difference between the 4 and the 0. This difference is going to give us the length between the 2 points. Now, there are 2 ways I can find this. I can find the absolute value of 4 minus 0, which equals the absolute value of 4, which equals 4, telling me that the distance between points A and B is 4. Or I could try it starting with the b. I could start with 0, and I could do the absolute value of 0 minus 4 gives me an absolute value of negative 4, which, guess what? Since we're talking about distance, it's always positive. It's 4 units. So you can see that I've used absolute value to find the distance between these 2 points. In the beginning of the lesson, I asked how far apart these points were on the number line. We had E and F. That's what they look like at 0, 4 and 6, 4. Now, these coordinate pairs share a y value. So we're going to find the difference between the x values to tell us the distance between these 2 points. Now, the absolute value of 0 minus 6 is negative 6, the absolute value of negative 6, because we're looking at distance, which gives us 6. That tells me that the distance between the 2 points is 6 units. Or I could try the absolute value of 6 minus 0, which gives me an absolute value of 6, which again is a distance of 6. In this lesson, you have learned to use absolute value to find distances between points with the same x and y value by using a coordinate plane.
Let's try a few together. First, let's find the distance between A and B, and then we'll find the distance between G and E. So let's start with A and B. We identify that A and B are both in the first quadrant, and we recognize that the coordinate of A is going to be 4, 12. Then we find the coordinate of B, which is going to be 4, 4. And since we see that the x coordinates are the same, we would subtract the y coordinates, which looks like this. There's the coordinate of A and the coordinate of B, and the absolute value of the y coordinates, 12 minus 4, is the absolute value of 8, which equals 8. Therefore, the distance from A to B we can count along the way. So we have 1, 2, 3, 4. Wait a second. We just saw that the distance was 8. Does anyone know why I counted 4, but I got the answer as 8? You're absolutely right. The increments on the y-axis and the x-axis are going up by 2. So each one of these equals 2. And when you add 4 2's, you get 8. Very good. So let's take a look at G to E. We see that the coordinate of G is negative 12, negative 8. And we see the coordinate of E is 4, negative 8. Well, again, we see that the y values are now the same, so we are going to take and we will subtract the x values. Now, I see that this is negative 12 minus 4, so let's see what that turns out to be. There is our G coordinate, negative 12, negative 8, and our E coordinate, 4, negative 8. And when we subtract, the absolute value of negative 12 minus 4 is negative 16. Absolute value of negative 16, which is a positive 16. And we can make sure that is the case when we count from G to E. We have 1, 1, 2, 3, 4, 5, 6, 7, 8. And since we know that this is 8 spaces away and each of them are 2, we take 8 times 2, which is 16, which is what we got when we found the absolute value of the distance between point G and point E. How would you like your backyard to look like this? I would love to have a swimming pool and a basketball court in my backyard. I'd also like to add a soccer field. That would be amazing. There are architects who specialize in backyard design for famous people and athletes like Tiger Woods. He has a 4-hole golf course, 100-foot lap pool, a hybrid tennis basketball court, private beach, and 2 docks for his yachts. Whoa! But there are also architects who design athletic facilities like the Ripken Experience in Pigeon Forge, Tennessee. It's a huge baseball complex. Or the Bob Lucido Fields at Covenant Park in Ellicott City, Maryland, not too far from Baltimore County, home of SAC, Soccer Association of Columbia. This is a huge soccer complex. This all requires knowing the area of the land and how everything fits. So let's practice what we know with finding the distance between 2 points to find the area and perimeter of a polygonal coordinate plane. So let's start with the perimeter. So what you see here is a polygon, a 4-sided polygon with vertices A, B, C, and D. So let's first find the distance between A and B. And we will see that the A coordinate is, oops, no, that's right. The A coordinate is 4, 6, and the B coordinate is 4, -4. So if we see that the X coordinates are the same, we would then use the Y coordinates to find the distance between A and B. And we would take the absolute value of 6 minus -4, which would equal 6 plus 4, which would be the absolute value of 10, and the absolute value of 10 is 10. So if we look at the distance from A to B, we can count. 1, 1, 2, 3, 4, 5. Well, it looks like this is also in increments of 2, so the distance from A to B is 5. Now, it looks to me that the distance from A to B is the same as the distance from D to C, so this side is also 10. So let's find the distance from D to A. The absolute value, the coordinate of D is -8, 6, and the distance, the coordinate of A is 4, 6. So here we have the Y values the same, so we would take the absolute value, the difference of the absolute value of the X values. So it would be the absolute value of -8 minus 4, which would give us the absolute value of -12, and the absolute value of 12 is just 12. So we can again count. So we would count 1, 2, 3, 4, 5, 6 to make sure that yes, every increment is 2. So therefore the distance from D to A is 12, and that also looks like the distance from C to B. So let's verify to see if we have the right answers. So we found the coordinates of the points of the vertices. We found A, B, C, and D. We found the lengths of the sides. We found that AB is 10. We found the length of BC to be 12, CD to be 10, and the DA to be 12. And then to find the perimeter, we would add the lengths of the sides, 10 plus 12 plus 10 plus 12, which equals 44. And so the perimeter of the polygon is 44 units. Well, how do we find the area of a polygon, which we learn now that since this is a 10 by 12, that this is a rectangle. To find the area of a rectangle, we would do length times width, and so therefore the area of this would be 12 times 10. Therefore, the area would be 120 units squared. So that's how you find the area and perimeter of a polygon on a coordinate plane. So now we have another example, and we're going to find the area and perimeter of this figure. I bet you all can look at this and pretty much tell me that this is a square, and it probably is a 3 by 3 square. Well, what if I wanted you to prove that to me? Well, you would find the distance of each side using absolute value and the coordinates. So let's go ahead and do that. So this coordinate here is 4, 1. This coordinate here is 4, 4. This coordinate here is 1, 4. And then this coordinate here is 1, 1. So the first side, we would take the absolute value of 4 minus 1, and we would get the absolute value of 3, which is 3. This side, we would take the absolute value of 1 minus 4. Absolute value of -3 is just 3. This side, we would take the absolute value of, again, 1 minus 4. Absolute value of -3 is just 3. And the last side, again, we would take the absolute value of 1 minus 4, which would we get the absolute value of 3, which we would get 3, which is exactly what we just said, that this is a 3 by 3 square. So in order to find the perimeter of a square, we can either do 3 plus 3 plus 3 plus 3, which we could get 12, or we could just do 4 times 3, which would give us 12, because there's 4 3's, and 4 times 3 is 12. And then the area is going to be length times width, which will be 3 times 3, which is 9, and we add square units. And up here, for perimeter, we would just say 12 units. Now we could also count the number of squares. 1 square, 2, 3, 4, 5, 6, 7, 8, 9, which gave us the area. And then if we wanted to, we could count the perimeter, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which would give us the perimeter. Excellent job. Let's practice plotting the coordinates, identifying what the polygon is, and then finding the area. So if we plot these 4 coordinates at -4, 0, 1, 4, 1, -3, and then back to -4, 0, because we would like to connect all of these vertices. And if we connect it, we connect the first one to the second one to the third, and then the third back to the fourth, which backs to the original, and it looks like we have a triangle. Now, if we remember in our last lesson, to find the area of a triangle, it is area equals 1/2 the base times the height. Well, if we take a look at this triangle, we identify the base as being this piece. That's the base. And then from the top of the triangle down to the base, we would identify as the height. So in order to find the distance or the length of the base, we're going to use the absolute value. This point here is 1, 4, and the point here at the bottom of the base is -3, 1, -3. And in order to find the distance between this point and this point, we would take the absolute value of 4 minus a negative 3, which would give us the absolute value of 7. Therefore, the distance is 7. So the base is 7. To find the height, we would need to go from this point to this point, which this point here is negative 4, 0. And the next point here is 1, 0. So we're going to look at the x values, and find the absolute value from negative 4. Let's erase that. Negative 4 minus 1, and then the absolute value of negative 5, and the absolute value of negative 5 is just 5. Excuse me. Therefore, the height is 5. So now that we know that the base is 7 and the height is 5, we can find the area is 1/2 times 7 times 5. The area is 1/2 times 35, and half of 35 is 17.5 square units. This week, we learned how to use absolute value to find the distance between 2 points and to find the area and or perimeter of a polygon on a coordinate plane. If we take a look at these 4 coordinates, A, B, C, and D, if we connected all of these coordinates, we look to find a 4-sided polygon that we learned about last week. Does anyone remember what this polygon is called? It had a really funny name. You're exactly right. This is our trapezoid. And if you remember, to find the area of a trapezoid, we would have to do 1/2 the sum of the bases times the height. And for this example, the distance from A to B would be base 1. The distance from D to C would be base 2. And the distance from B to C would be your height. So you now can find the area of a trapezoid on a coordinate plane using absolute value. Great. Well, it was sure great to be your host again. Continue to do your best, stay healthy, and wash your hands. Just a reminder, Miss Barr will be your host next week. I cannot wait to watch her. Until next time, always remember, math is fun.